Hello, everyone, and welcome back to your Physics 121. Hello, everyone, and welcome to your Physics 121 concept session on free fall with an initial velocity. My name is Nathan Martin, and I work for the tutoring centers at ASU. So this problem, we're given a rock is thrown straight up from the ground with an initial velocity of 6 meters per second. What is the maximum height this rock reaches, and how fast is it when it reaches this height? Okay, so before we kind of get started, I'm just going to draw a little picture of what's going on. So, right, this is the ground. We're throwing something straight up from the ground, right? Straight up, right? It reaches some maximum height, and then it falls back down, right? So here's the ball, maximum height, comes back down, right? So this maximum height, I'm going to call h. So that's the height that I want. That's the maximum height that I'm trying to achieve. Okay? So this problem, right, it's basically telling us, you know, it's hinting at us, so to say, to use the kinematic equations. Okay? So again, I've been stressing this in the previous videos. Kinematic equations you can only use, okay? You can only use the kinematic equations when your acceleration is constant. Do not be that fool that uses the kinematic equations when the acceleration is varying, okay? I cannot stress that enough. These equations only work with a constant acceleration. Okay, so what I'm going to do is just pick one of these kinematic equations. The VF squared, so the final velocity squared, is equal to the initial velocity squared plus 2 acceleration times delta x. Okay, I'm going to pick that one to start with. Now, if you've watched previous videos of kinematic equations, what I do is I make a kind of chart and mark everything I know and don't know. Okay. So my final velocity, we'll start there. Do I know this final velocity? If you're kind of reading this question, you would say no, right? I don't see a final velocity. But we're trying to find the maximum height, right? So the max height, right? If you're looking at this picture, the max height occurs here, right? Obviously in the picture, because I've drawn that to be the max, right? So the maximum height occurs when that final velocity, i.e. that velocity at the max, is equal to 0. Okay? And this is kind of a throwback to your calculus days, right? If you have some function, I'm going to draw it up here, right? If you have some function, the maximum, right, that would be the maximum. The maximum occurs when the derivative is equal to 0, right? So in our case, our displacement, right, we're trying to find a maximum height, that's a displacement. The maximum height occurs when the derivative is equal to 0. So the maximum height occurs when your velocity is equal to 0, right? Because velocity is the derivative of your displacement. So that final velocity equals 0. And if you kind of reread this question, right, how fast is it when it reaches this max height? Well, dang, we've already solved half this problem, right? That is the maximum. That's how fast it's going when it reaches that max, 0, right? If that's not kind of clear to you, I do highly suggest kind of rewinding a little bit and kind of follow that like logic that I was, you know, talking through. That's very important. Okay, so let's get back to this topic, okay? Do we know the initial velocity, v naught? Yes, I do, right? It's given to me. 6 meters per second. Do I know the acceleration? Yes, I do. That's equal to the acceleration due to gravity, right? We're assuming no air resistance. So that means the only external force acting on this rock is the force due to gravity. So that would be G, which is approximately 9.81 meters per second squared. And lastly, do we know delta x? Well, in here we say it's the maximum height, h, right? But do we know that? No. We want to solve that. So cool. Let's look at this kinematic equation. I know the final velocity. I know the initial velocity. I know the acceleration. I do not know delta x. Therefore, I have one equation with one unknown. So one equation, one unknown. I can solve this thing. Okay. So I'm going to solve for delta x. So delta x, well, that's just equal to h, right? We said delta x is h. So h is equal to the final velocity squared minus the initial velocity squared, all over 2 times the acceleration. And now, from here, all I have to do is just substitute all these variables. So the final velocity, that's 0, minus the initial velocity, which is 6, so I gotta square that, all over 2 times the acceleration, 9.81. And now, if I were to solve this thing, I find that this is about, if I throw this in my calculator, it's about negative 1.83 meters. Okay, so now I want to kind of introduce one more topic. I'm going to say this thing, okay, because I don't. If you walk up to someone and say, oh, what's the maximum height this ball reaches, and you give it a negative number, they're going to be like, well, what are you talking about? Why is it negative, right? I want to discuss why we got a negative answer, and I want to discuss how we can make this positive, okay? This discussion we're going to do in green, okay? So we said that the acceleration due to gravity is 9.81 meters per second, right? Well, I know gravity, it acts downwards, right? What I could have done is say that this is equal to negative g, right? Because it's acting downwards. See how if I then introduced another negative down here, the negatives would cancel each other out, right? Because a negative divided by a negative gets you a positive answer. So in order to fix that, we just have to say, oh, acceleration is acting downwards, it's negative. Which is completely reasonable to do, right? Because we're assuming the initial velocity, v naught, is going up, right? And since v naught is going up, that's a positive, right? V naught was positive. See how we said it's positive? So if your initial velocity is going one direction and the acceleration is going a different direction, what we should have done is included that negative g, right? We should have said the acceleration is equal to negative g, negative 9.81. Therefore, the expression would have been positive. If you do get a negative height or something like that, I do highly, highly, highly encourage you to go back and look at your steps, right? Which is, it's very easy to go back and look at your steps because we've solved it in terms of letters. This is the beauty of solving things in terms of letters. Everything makes sense, right? See how your final velocity minus an initial velocity? Well, your final velocity is 0, right? This initial velocity is always going to be negative, right? So you're going to have a negative in the numerator. In order to make the entire expression positive, that acceleration has to be negative. Thus, we can kind of backtrack and see, oh, I said my acceleration was positive, but does that really make sense? I mean, in terms of magnitudes, it does. But physically, looking at this picture, I've drawn the acceleration due to gravity in the opposite direction as that initial velocity, so I should include that as a negative. Okay, moral of the story, the answer should be positive 1.83 meters per second. Cool. So let's clear all that up and talk about our tutoring services. Okay, so if you would like more information on our tutoring services, such as our hours of operation, locations, review sessions, all that good stuff, you can go to our website at tutoring.asu.edu. And again, all those resources are completely free to you. And if you want to watch more of these concept videos, just like the one you're watching now, go to this link here. Thank you all for watching this, and we'll see you in the next video.